Welcome back, everyone. Consider the structure HCOOCH3. Number 1, draw its appropriate Lewis structure. And number 2, identify the types of orbitals used by each carbon atom for bonding and estimate the bond angles around the carbon atoms. So first of all, we can recognize the structure, right? It is an ester because it has a form of RCOOR. So essentially, whenever we have an ester for number 1, we can begin by drawing that carbonyl. Let's begin by adding carbon, which is going to be double bonded to oxygen. Now we notice that this carbon is bonded to hydrogen. And then, since it is an ester, well, we simply want to introduce an alkoxy substituent, right? So oxygen, which is then bonded to CH3, a methyl group. So carbon with 3 hydrogens. We want to make sure that for our Lewis structure, each carbon atom has 4 bonds. We notice that the first one has 1, 2, 3, 4 bonds. The second one has 1, 2, 3, 4 bonds as well. Oxygen atoms must have 2 bonds, right? So this is exactly what we have. And oxygen atoms will have 2 lone pairs of electrons based on the octet rule. So we have the Lewis structure, which satisfies the octet rule for each atom except from hydrogen, which follows the duet rule. It must only have 1 bond. And now we can proceed with part number 2 of the problem. First of all, we want to identify the hybridization of each carbon. Notice that the first carbon has a hybridization of sp2, since it has 3 electron regions, 2 single bonds, and 1 double bond, right? So 1 plus 2 gives us 3. sp2 always corresponds to the steric number of 3, or a total of 3 electron regions. While the second carbon has an sp3 hybridization because it has 4 electron regions, 1, 2, 3, 4 bonds, right? 4 sigma bonds. So essentially, knowing these hybridizations, we will be able to identify the types of orbitals. What we're going to do is basically redraw this structure. And we can also remember that sp2 hybridized carbons, they form trigonal planar geometry. So we can add appropriate bond angles to our structure. And sp3 hybridized carbons, they are tetrahedral. So now we're going to use the given picture and assign the bond angles. Starting with the first carbon, we want to remember that sp2 hybridized carbons are trigonal planar, so each bond angle is going to be 120 degrees. So we have our bond angles for the first carbon. For the second one, since it is tetrahedral, each bond angle is going to be about 109.5 degrees. Well done. And now we want to identify the orbitals for each bond. First of all, we're going to begin with the carbon atom that contains carbonyl. And we understand that there are 3 sigma bonds. Those sigma bonds are formed from the same sp2 orbital. So what we're going to do is basically state that the 2 bonds, which are the 2 sigma bonds, the first one between carbon and hydrogen and the second one between carbon and oxygen, those would correspond to an sp2 orbital. Then we have our double bond. Our double bond consists of a sigma bond and a pi bond. Let's recall that the sigma bond is going to also have an sp2 orbital. but the pi bond belongs to the p orbital, which is non-hybridized, right? And now considering the other carbon, well, essentially we have 3 carbon-hydrogen bonds. They are all sigma bonds because they are part of a single bond, and therefore they will correspond to the actual hybridization, which is sp3. The remaining is the carbon-oxygen bond, which is also a single bond, right? So we're going to have an sp3 hybridization again. So simply speaking, each bond will correspond to the hybridization of the carbon atom, except from the pi bond of the double bond, which is going to be the p orbital overlap. And that's it. We have our final answers. Let's label them, and thank you for watching.